Hello everyone, welcome to the series of variations. So in today's lesson, we will be learning about a concept which is called as non-neighboring Fibonacci representation. We can also call it as Zeckendorf's theorem. See, Zeckendorf's theorem states that every positive integer can be written uniquely as a sum of distinct non-neighboring Fibonacci series. See, two Fibonacci numbers are the neighbors if they come one another after the Fibonacci sequence. If we will see the Fibonacci sequence 0, 1, 1, 2, 3, 5, then 8, then 13, then I guess 21. Yes. Okay, so this is the Fibonacci sequence. For example, 3 and 5 are the neighbors, right? But 2 and 5 are not the neighbors. So given a number, we have to find a representation of the number as the sum of consecutive Fibonacci numbers. For example, if the given input is 10, if we will say that input is equal to 10, then the output should be, which are those consecutive numbers? That is, of course, we have to find out the non-neighboring Fibonacci numbers, right? So it will be 8 and 2, right? Because 8 and 2 are non-consecutive Fibonacci numbers and their sum is also equal to 10. Similarly, if n is equal to 21, 30, then 30 we have to find out. Now if I will say it's 34, 13 and 21, 34, 21 and 8, it's 29. Okay. And if I will add 1, it will become 21, 8 and 1. This will become 30 and they are also the non-consecutive Fibonacci numbers. So the answer will be 1, 8 and 21. So this is how this is a question which we have to find out. Now what we have to do, we will use a way which is called as the concept of greedy algorithm, which we have already gone through in another video. You can also go through that video so that you can just revise it from there. Now what we will do, let n be the input number. While n is greater than number, this is the input number, it should be greater or equal to 0 first of all. Then we will find what? We will find the greatest Fibonacci number smaller than n, right? That number should be smaller than n. If we are saying 30 is the input, whatever numbers which we have find out, they are also the smaller than n. Now let this number, whatsoever number it is, let this number be f, and we will calculate it how? By using a way I will tell you. Let me just show you over here. So we will just use a formula over here. For example, if n is equal to 30, why it's in caps lock? N is equal to 30. Okay, so I will just call the method non-Fibo. I will just call it as non-Fibo. Now what I have said, it should be n should be greater than 0, so I will write if n is greater than 0, okay, if n is greater than 0, then we will do what? Find the greatest Fibonacci number. Find the greatest Fibonacci number which is smaller than or equal to this n. Okay, so I will be taking a variable f and I will find out the smaller Fibonacci number now. First of all, I will find out the smaller Fibonacci number which is nearer to it. Okay, and after that I will print that f. We have to find it, by the way, and after finding it we will reduce the number of f, so n minus f. That is very simple. Now I have to create this method. Let me just find out it now. The nearest smaller Fibonacci number. How am I going to find that out? So what will I do? We know if n is equal to 0 or n is equal to 1, what we are supposed to return? Return n again. So now we will find the greatest Fibonacci number which is smaller than n. How? We know, I will take some variables, say f1 is equal to 0, f2 is f2 is equal to 1, and f3 is also equal to 1. So we know how to calculate it. If f3 is less or equal to n, what will I do? We know the logic of it. f1, save the value of f2 in it, and in f2 save the value of f3 in it, and f3 should be equal to f1 plus f2, right? And after that we have to return the value of f2. That's very simple. See, the answer is 28, 8 and 1. So firstly it will find out the value 21, then it will find out the value of 8, then it will find out the value of 1. So this is how we will find out the non-neighboring Fibonacci series. Hope you guys understand it. Thank you very much.